So, on the previous video we finished up with the lobby and we had to wait and see with what we're basically going to do with prediction and stuff like that. So the theory of prediction is basically you don't sync everything on every frame as you will normally or as you usually do in single player basically. Okay, because we want to be conservative with the packages we're sending. Okay, and because there's also no need to, because if you are sending it on, you know, on an interval of a few milliseconds, doesn't mean that your player is going to be flash and, you know, going to send or basically change his direction on that little of milliseconds. Okay, so what it is, so let's say you have a character. I know you're going to be amazed by my awesome drawing skills. Okay, and the character is moving one way. And so basically what we're doing is after, or well, let's say 10 milliseconds, or it doesn't matter, we're not going to go with milliseconds, we're just going to go with frames, but you can change basically, you know, the send rate. You can change it to whatever you want. We're just going to see a simple example. Okay, when he's moving towards there, then that means that under 10 milliseconds he's not going to change directions. So what we are doing is we're saying that when he's going to start, we tell to the client or to our own objects, you know, start walking towards that direction. Okay, that can be alert, that can be an addition. We're just going to go with both of these. Okay, so he's going to be moving that direction, and in 10 milliseconds we're going to validate that, you know, keep walking towards that direction, otherwise walk towards another direction, rotate, you know, jump or aim or do whatever you want. So the trick is that we're going to be sending information under every, or well, a basic on a send rate, which we're going to check, and we're going to see how we're going to do that. And the dummy controller right now is going to control, basically it's going to be responsible in rotating the character, moving the character and moving him until we have validated that he changed his direction and he changed his position. Okay, really basic. It's not something weird, or we're not actually reinventing any wheels over here. Okay, this has done, and this has been doing the, you know, this has been done from the age of yeah, I'm pretty sure it was happening way back, even from the first ages of multiplayer. I don't know which was the first multiplayer game that existed, but if you know, then let me know. I'm guessing it was either probably something like Quake or Doom. I'm guessing. I'll have to check that on that. But yeah, I wouldn't be surprised if that was one of the first multiplayer games. Although I guess, yeah, I think the first didn't they play Pong? Yeah, I need to check on my history. But I think, yeah, the first multiplayer game was actually probably something like that, something like Pong or something. I don't know. Or if that was the first game ever. Anyway, doesn't matter. Anyway, so we have the game object we are creating through the lobby, or well, UNet is creating. Okay, and okay, so we have our multiplayer sync. Our send rate is going to be 10, so that means on every 10th frame we're going to be sending our messages. Movement threshold is going to check if the player has changed position more than 0.1, then he's going to actually sync the position, otherwise he's going to ignore it. The same with the angle threshold, which is basically you know, 5 degrees angle. It's not going, everything lower than 5 degrees is not going to bother syncing it. level name, model ID, main weapon, secondary weapon, we have seen this. The animator we are creating, of course this is going to be the same, well, it's this animator. The rigid body, we have a rigid body. Notice it's kinematic because we don't want things flying off. The character, well, the dummy, we don't using it anymore. And if we have received the level, or if we have initiated our well, with the character, the controller is basically has initialized. Let's open the multiplayer sync. We've seen all this in the previous video, what they are doing, so we're only going to focus with the local player and then of course the dummy player. So on update, if you haven't yet initialized, then don't do anything. If you are the local player, then play the update we have for the dummy player. Otherwise, not otherwise, in any case, just do count. It's going to check if our count over here is equal the send rate we have, and if it is, going to reset back to 0. If not, then it's going to be adding on the count, so that means it's going to be checking for frames. That means you have 60 frames, okay, per second, and you are only sending messages on every 10th frame, assuming you have a constant frame rate of 60 FPS, then that means you are sending by 10 milliseconds. Okay, 1/10 of the second, basically. Not 1/10. Well, anyway, you got the idea. It's morning, so I can't do math. Okay, if it's the local player, then we are syncing a local player tick, dummy player tick. Okay, and actually, because I'm curious right now, and yeah, as you can guess, I've actually went to Google and searched which was the first multiplayer game ever existed. This is important, people. Pay attention. Okay, I need to know this. So yeah, from what it looks like, it was, let's see, it says on 62 it was an early racing video game such as Astro Race, or no, these are probably just examples. The first examples of multiplayer real-time games were developed on the Plato system about 1973. Okay, and it says about some first-person shooters and stuff like that. Anyway, doesn't matter. As you can see, they are from multiplayer games existed long before World of Warcraft, for some of you. Anyway, okay, local player tick. So this stays the same basically as we had before for the most part, but right now we're only sending him or sending the messages on an interval of 10 frames every 10th frame. Okay, so we're still checking if previous aiming, and then we're sending the aim. All this stay the same. Will also stay the same, the local player late tick, which is going to be sending the position and the move input. Okay, but inside the late update we're going to also add, if he is not initialized, then return. If the count is not equals the send rate, then you're going to return. Otherwise, if you are still the local player, then basically sync the position and sync the move input. Okay, otherwise you are sending the update on the dummy, or that you're doing the dummy update, basically the dummy tick. Now, okay, till now everything is basically the same thing. We haven't changed anything, but on the send position, you can see, of course, we are doing the RPC for this, and we have the RPC receive position. If the local player, if you are not in it, then simply return. Otherwise, here's where it becomes interesting. So we need to know the speed, because we want to calculate the speed we are going to be lerping at, And to calculate that, we need to actually have our send rate plus 1, just in case send rate is going to be 0, because we're going to do division over here. Okay, so we know that we're never going to divide by 0. Then we need to know the last direction from our dummy controller, and probably it's best to see the variables we're going to use first. Okay, we're going to use all of this, as you can see. So basically, let's go over them. Okay, rotation speed, lerping speed, the snap distance, and the angle snap. Snap distance is basically saying that if your character has a difference of over 4 points, it's going to teleport the guy onto the position instead of lerping it. Same with the angle. If it's over 40 degrees, it's going to snap on that angle. We have horizontal, vertical, on ground, aiming, run, reloading. Okay, all this stuff, we had them before. Same with the aim position. For the aim position, we won't have any lerping for right now. We're probably going to have to add prediction to the aim position as well, but we're going to see in the future if we actually need it. We're probably going to need it, I believe, but we'll see. We'll see how we handle that. Well, the aiming, you know, it's not movement, it's kind of weird, and even if it doesn't look at the same position, as long as it's towards the same direction, then probably nobody is going to notice it. Okay, last position, last direction, which is what we sent last time. Last rotation, movement threshold, and the angle threshold. And we have our animators, bone helper, of course, a rig type, main weapon, secondary weapon, which we initialize with this. When we initialize the dummy controller, we pass the main, secondary, okay, and we have everything. For the rig type, we're just going to assign as default, okay, since I only have the default, but if you have different characters with different rigs, you also need to be syncing the rig type along with the model type. Okay, and then we initialize everything else. So, before we see the tick, let's see how we send all of this, how we populate all this data. Back to the multiplayer sync, we are over here. Again, we send the frames, we say why we add the 1, okay, just so that we never divide by 0, just in case somebody changes the send rate to 0. The last direction is basically our own current position, or the position where the target position we're passing, minus the last position we had before. We're going to subdivide the frames by frames, the last direction by frames, and we do that because we want to check with the magnitude and the movement threshold. Okay, and we check basically if the movement threshold or the magnitude of our last direction is not as doesn't surpass the movement threshold. We basically saying that you don't have any direction, so don't do anything. Then we start checking the last Euler. Okay, we take the rotation, the last rotation we have passed, the Euler angles, because it's easier to work with the Euler angles, and then we also need to assign the new Euler. We have a rotation. Okay, from the rotation we are passing over here, we take the Euler angles, and then we're doing the angle check. Basically, it's going to compare the angle between the last rotation we had and actually, okay, this is it. Between the last rotation and the rotation we are passing right now, it's going to check if it's lower than the angle threshold. If it is, then the last rotation we want is basically this. Yeah, this is going to sound confusing. You basically have the two Eulers, which is this gives you a direction between the last and the new Euler, and we subdivide by the frames. If you don't know why we subdivide a vector 3 by frames, let's check it out. So as I was saying, okay, basically it just scales the vector, or you can check it like this. You can Google division for vectors and you'll get into some interesting discussions or whatever. Okay, for right now we're just using it as scaling, although you know you can normalize it, you can do whatever you want. It won't really matter with over here. It just basically it scales the direction or the directions basically on the frames you are sending them. Okay, that's all you need to know to work with this. It won't really matter. Otherwise, if your angle threshold is higher, then the last rotation will be 0. Okay, and then we're passing this to a last position and last rotation. For the rest of the commands, as you can see, it's all the same. The input is basically the values we are passing on the animator. Okay, and you can see that everything else has stayed the same. We're just passing booleans over here. We don't want them, all of them, or well, you can try and add them all in the same message, but you know there's no need to, because you know, on the same frame you are running, you're probably not going to be reloading also, although you can. Doesn't mean that you will always be on the same one. Okay, same with the on ground and same with the rest of the stuff. So let's see the dummy controller where all this actually comes into play, which is really easy. Okay, we have our tick. Basically while we are doing prediction, we have them on the same function, but before we see that, let's see all of this. So basically what I'm doing is checking all the on air, on ground, okay, all of that. We're passing it on the animator. You can see that for the animator we also have, you know, a built-in crossfade or whatever you want to call this. So basically we don't really have to worry about the 10 milliseconds because it's enough time until it changes the values on the animator. It's enough time, the 0.4, it's enough time to make it blend seamlessly without having to worry about, you know, making the animations feel a bit too frantic, because we are sending every 10 milliseconds we are sending different values. Okay, which is what we actually want. Okay, so if in case we are loading, then we don't have the way we have added our reload is basically we don't have any booleans. We're just going to go and play directly the animation. Right now we're just using a rifle reload. Of course we only have one animation, which is the rifle, one reload animation, which is the rifle reload. So what you can do with this is basically just yeah, later on we're going to be adding checks with the weapon, and if we have different reload animations and all stuff like that. Okay, all that stuff don't have to go through the network. We're just saying reload. We know what weapon we have, and we know what we know that we want to reload. Okay, we don't have to wait till to pass through the network that you want to reload your weapon. You already have your weapon, so you also know what animation you want to play. Okay, all that is of course theory, because we only have one animation for reloading and it's this one, so we're just going to play this one. For prediction, which is why we're all here, is basically we get a current position. Of course it's from our transform position and rotation. We have our distance between our last position and our current position. Okay, if you don't want to be like me, you can do it like this, it won't matter. Okay, we have the distance and we have the angle. If the distance is greater than the snap distance, put him directly on the last position. If the angle is greater than the angle snap, put him on that rotation. If not, and here's the trick, okay, if not, notice that before we actually do any lerps, we are actually adding to the current position, we are actually adding the last direction we are moving, and so that's why we are scaling both the direction and both that rotation. Okay, so basically you have your position. Before you actually interpolate towards the other position, we are also adding to that last direction, so everything feels smooth. So even if you pass the lerp, okay, if you pass the last position and you haven't yet received a message that the position has changed, you're still adding and you're still moving. So that's why you've probably seen this on a lot of videos. It was also a meme, you know, when somebody disconnects but you still see him on your own game, and he keeps walking and he keeps walking until he reaches a wall, and he's walking to the wall. Okay, I'm pretty sure you have seen this. It's everywhere, and it was everywhere. Okay, and that's why it happens, basically because of prediction, because you're adding it to the position until you receive the message that the player has stopped moving towards the direction or stopped rotating towards the direction. Okay, that's basically it. That's the same thing we're doing with the position. And of course, for the rotation, because it's a quaternion, you don't add. If you want to add 2 quaternions, you multiply the... Okay, that's it. And this could all actually be a slurp. Target position, target rotation. Load weapons, we've seen all this already. Okay, now one thing to notice, because we are using events, I think I've covered this also 2 videos back, because we are using events inside our animations, because we want to reuse the same animations and the same animators. Okay, we just have the events, but for right now we just comment them out, and we're going to see and to enable them later when we actually want to worry about with the weapons. So that later it's probably going to be the next video, I guess. Yeah, so that's, for the most part, that's it. Okay, you can have multiplayer game. We've seen everything, well, the basics of it, and on the next videos we're going to pass also the models, well, the modifications for the weapons, you know, because it's fun and why not. We're going to see also one more technique, although it's something we've also seen in the past, that we're going to piggyback information into the strings we are already passing, and then breaking it up and then using each section. And we might see, actually, although it might be just a little bit too soon for that, we basically just want to make lookup tables so that we're not passing strings, because a string, you know, there's no end to a string. Okay, well, there is an end to a string, but you can guess that it can be a lot of characters. Okay, depending on the limitations. I have to check the limitations for Unity, actually, for the strings. And yeah, so as I was saying, because there's no end to basically how many characters a string can pass, we're just going to create a lookup table. Okay, so we're going to basically, a lookup table is going to be a dictionary, so it's going to say you that if you pass the number 22, it's a random number, then that corresponds to that string, and that string can be, you know, assault rifle number 5. Okay, of course you don't want to pass a string that large, although if you're only passing it once, to be fair, if you're only passing it once through the network, then that means, okay, nobody is going to care, but it's just, you know, just to play it safe, or just to learn a few good practices, we're going to create a lookup table. So instead of strings, we're going to be passing through the network integers, which then in turn those integers are going to translate into a string from the lookup table we're going to create. Okay, those are the 2 things we're going to see. We're going to see how we can have finally spawn positions and, you know, startup scenes for the main game, maybe timers, we're going to see, but yeah, we still have a lot of stuff to cover, and we haven't even finished that. But for the basics, yeah, with this you can take all this and you can create a lot of multiplayer games, and everything we have done up till now, it's going to be the same. Doesn't matter the game, even if it is you know, for any real-time game, because if you are doing any turn-based, okay, stuff like that, things are far more easier there, because you don't necessarily need any prediction, because everybody's playing on their own turn. So when somebody ends their turn, you simply want to pass basically the action they did. Okay, so things are way easier and simpler there. So for any real-time games, this will work for, you know, probably more than 9% of the cases. So we're going to end it over here. We still have a lot to cover, and yeah, we're going to see some pretty cool stuff in the future. So you know what to do: like, subscribe, share it if you can. If you also like to see more, and if you also like to continue making all this, because not only they take time, they take resources, and they take you know, time away from other work, then your support is really much needed and appreciated. The ways you can support me is either through Patreon, okay, which also check also the rewards over there. Depending on the tier you are pledging, you also have more rewards. And the other way you can support me is, of course, through Gumroad, by buying a project or two, so I can continue making all of this without having to worry taking away time from other work. So I'll see you next time.